Here is an explanation for the answer to final exam, question number 95, in Electronics Demystified, 2nd edition. If you have the printed book, you'll find it on page 438. We're talking here about a geostationary satellite. That's one that always appears to stay in the same position in the sky as seen from any point on the Earth's surface. In order for that to be true, the satellite has to meet certain criteria. It has to be orbiting at an altitude of about 35,800 kilometers or 22,200 miles. It has to be orbiting from west to east, that is counterclockwise as we would see it as viewed from above the Earth's North Pole, in the same direction as the Earth rotates, that is. And it also has to be above the Earth's equator. It has to be right above the equator, so a line running from the center of the Earth through the Earth's equator would intersect this satellite. If it's north or south of the equator, it won't stay in the same place in the sky all the time. So it has to meet very specific criteria. And again, what we're looking at here is the Earth viewed from right above the North Pole, so that the Earth appears to rotate counterclockwise once every 24 hours with respect to the Sun, or once every 23 hours and 56 minutes relative to the distant stars. And we have here an example of a dish antenna transmitting and receiving along this signal path to and from this geostationary satellite. Now, what will happen if the satellite's orbit decays so that it becomes less than this critical 35,800 kilometers? What are we going to see? Well, you have to think a little bit to answer this question properly. If a satellite falls to a lower orbit, it's going to orbit faster. That means that it's going to get out ahead of the Earth's rotation and appear to drift from west to east. If it were to increase in altitude, it would orbit more slowly, thereby lagging behind the Earth's rotation and drifting from east to west. But we're being asked here what happens if the orbit gets too low, less than this critical value. We're going to see it drift in the sky from west to east, and the further it decays, the faster that drift will be. But we can't accept any drift in a satellite like this if we're going to have dish antennas here on the Earth's surface, like the ones that you have, say, in your satellite internet connection or your satellite TV or any other satellite connection. These are usually anchored in place. You don't want to have to fiddle around with it. You want to be able to set it and forget it. And hopefully a windstorm or ice storm or a stray eagle won't fly into it and knock it out of place. But you want this antenna to be fixed so that it always points at the satellite, and you don't want to have to fool around with it. So these satellites do eventually get out of whack. They get out of alignment, and they have to be readjusted to get them back exactly where they belong so that they appear to stay in place. That is, they remain geostationary. But again, the correct answer to this question is B. If the thing falls to too low of an orbit, it is going to get out ahead of the Earth's rotation and therefore appear to rotate, or drift rather, through the sky from west to east.